Let's do a few more examples of integration by parts. Practicing the rule of LIATE for prioritizing the choice of u when we're picking. And just to reiterate, remember, if we're trying to solve something using integration by parts, the goal is to first pick u and dv so that we can use the rule to determine the antiderivative by uv minus integral v du. And also in this video, I wanted to do an example where sometimes you may need to integrate by parts more than once in very specific types of situation. And let's just go ahead and see how that could happen. So let's say we were trying to find the antiderivative of negative 5x squared e to the x with respect to x. And, like usual, we could pass through any multiplier constant through the integral first if we wanted to, or we could leave it in there, but I usually would prefer to pull the multiplier out first. And again, so we have something times something, which is an indicator to possibly want to use integration by parts. And if we were to try to pick, well, what would u be? Remember that exponentials are always last in the list. We generally do not want them to be u for reasons. And algebraic functions like any polynomial would take precedence to e to the x. So let's go ahead and do that. So we'll set u to be equal to x squared, and that leaves everything else in the integral e to the x dx as dv. And as usual, we want to take the derivative of u, which would be 2x dx, and take the antiderivative of dv, which would be e to the x. And now that we've solved those, we are ready to go with using the integration by parts formula. And as a reminder, if you do pull out any constants or multipliers or whatever first, you need to make sure that you're multiplying by both the terms in the expansion of integration by parts, because the integral of u dv is equal to both uv minus integral v du. So this negative 5 should distribute to that whole thing. So again, we'd have, well, u times v minus integral v du. And here du would be 2x dx. And what I notice about this next example is we still have x times e to the x. So this is what I was saying like just a minute ago, is that sometimes we need to use the integration by parts formula more than once. Because notice that we started with x squared times e to the x, and after applying the integration by parts formula once, we end up with x e to the x, and 2 of course as well. So, and we could even clean this up by writing this as 2 times the quantity x e to the x, because we had e to the x times 2x. So, but if I write it like this is a little bit more of a normal way of writing it. But we still have a product of x with an exponential function. So since there's two different things, again, I could use integration by parts once again. So now on the next one, we could again call it u and v, or a and b, or whatever, but let's just go ahead and do a u substitution again. I'll just call it u2. And again, by LIATE, we'd want to pick x to be our u, and then that would leave dv to be everything else. So then we'd have dv2 is equal to, again, e to the x dx. And now du2 would just be dx, and v, the antiderivative of dv2, v2 would be just e to the x once again. And notice that, like, in our first stage, we started with x squared and we differentiated to 2x. In the next stage, we had x and we differentiated to now just down to 1. And we shouldn't need to have to do it again. But let's say, for example, you had x to the 4th e to the x, or x to the 5th e to the x. The thing with multiplying by e to the x is when you do dv, it doesn't ever go away. So we're going to get consecutive derivatives on the inside of our integration by parts, and we're going to have to do it over and over and over again. But anyways, this would leave us with everything else remains the same. And then I have -2 multiplied by, well, again, I would need to do uv minus integral vu. And I'm just going to do it with my second iteration here. So I would have u2 v2. So again, uv minus integral v. And now du2 is just dx. So applying this once again, I would have all this. And now this is, now I'm down to the point where I can just straight integrate e to the x, which is just e to the x. So applying the final distribution here, let's start with the innermost parentheses first. We'd have -2x e to the x plus 2 e to the x. And of course, we would have plus c as well at the end. And we could even distribute the -5 into there if we wanted as well, or leave it outside. But since I'm running out of room here, that will be good enough for now. In the next video, we will do another example.